Today we're going to continue our discussion on factoring, and we're going to specifically be talking about trinomials, polynomials that have three terms that are in the form x squared plus bx plus c, meaning the number in front of the x squared is a 1. So that's, to me, that's our simpler version. Okay. Now in Algebra 1, we learned how to use the generic rectangle to help factor, and we're going to do that in our next lesson, but I don't think we need to do it for this specific case. So when you have a trinomial, three terms with a 1 in front, I think we're going to kind of think about reversing FOIL. So real quick, let's FOIL this, right? So when I multiply the first, I get x squared. When I multiply the outside, I get a negative 10x. When I multiply the insides, I get a positive 3x. And when I multiply the last pieces, I get a negative 30. The reason I'm kind of writing it out this way, I didn't do it the other day, is that I want us to see again that the inside terms, when I combine those, will give me a negative 7x. So we have x squared minus 7x minus 30. Okay, here's what I want to point out. Our x times x, great, gave us x squared. Let me go back. Our goal today is to reverse this, to start here and then turn it back into these two binomials. So we're going to look at this. We're going to say x squared. Well, the only way to get x squared is x times x. Great. So then our job is to figure out what these numbers have to be. All right, well, let's take a look at these numbers. When you add these numbers, you get negative 7. When you multiply these numbers, you get negative 30. So we're trying to find numbers that add to negative 7 and multiply to negative 30. And there they are, positive 3 and negative 10. Okay, so our goal today is to figure out what numbers have to go here if we're reversing this. Okay, all right, let's take a look at these. So we've got x squared plus 12x plus 32. Our goal is to turn it into something that looks like this. So again, we know the only way to get x squared is x times x. I need to figure out what numbers go here. All right, I need two numbers that add to positive 12 but multiply to positive 32. So I'm just going to jot that down. What numbers multiply to 32? Well, you've got 1 and 32, you've got 2 and 16, you've got 4 and 8. I think that's it. Great, so now I'm going to look at that list and say, of these pairs, which ones add to 12? And I think it's these right here. So I need to add to 12, so I need both of them to be positive. And yes, a positive 4 times positive 8 multiply to be a positive 32. And so my answer is x plus 4 times x plus 8. The neat thing about factoring is that we can, I think, very quickly check it by multiplying it back out, right? By FOILing. So we get our x squared plus 8x plus 4x, perfect, and then plus 32. Awesome. All right, let's come down here. M squared minus 7m plus 12. Our goal is to unfoil it, essentially, right? So we know our first pieces are going to give us m squared. So the only way to get that is m times m. Great. Now I'm looking for numbers that multiply to positive 12 but add to negative 7. All right, so we're going to have to think about that for a second. Let's start with multiply to positive 12. We're thinking 1 and 12. We're thinking 2 and 6. We're thinking 3 and 4. Those are the only factor pairs, right? Now, if I need to add these, first of all, if we're going to multiply to be a positive, all of these have to have the same sign. But they can't both be positive or they'll never add to a negative. So I think they're both going to have to be negative. So now I'm checking. When I add those, I don't get negative 7. Don't get negative 7. It looks like those are my numbers right there. So I have m minus 3 times m minus 4. And one of the things we talked about in our last lesson was it doesn't matter which order those factors come in, right? As long as you have an m minus 3 on your list and an m minus 4 on your list, right? So those are the same answer. You might remember using a generic rectangle, and we will do that. I just don't think we need it here. All right, let's take a look at the next one. I have t squared plus 4t minus 60. So again, my goal is to turn this expression, 3 terms, into these 2 binomials that are being multiplied together. All right, so we've got t times t, that gives me my t squared. I need numbers that multiply to negative 60 and add to positive 4. Whew, let's worry about the negative later. Let's just worry about multiplying to 60. You've got your 1 and your 60, you've got 2 and 30, you've got 3 and 20, you've got 4 and 15, you've got 5 and 12, you've got 6 and 10. Whew, I think that covers all of them. I'm going to refocus this. That's a lot, right? Now, if we need these factor pairs to multiply to a negative, that means we need to have opposite signs, right? So keep that in mind, that these are going to be opposites. And if they're opposite signs, when I go to add them, we're really going to subtract, aren't we? So again, I'm looking for pairs that will add or subtract to 4. And I think the only one that's going to do that is here. I need them to have opposite signs, but add to a positive number. So a positive 10 and a negative 6. Right? Because 10 minus 6 is positive 4. Good. Sorry about crunching space there. All right. Now we have a squared minus 10a plus 25. All right. So we've got a and a, right, to get a squared. We need to find numbers that multiply to positive 25 and add to negative 10. So the only 2 ways I can get to 25 is with 1 and 25 and 5 and 5. I need them to add or subtract to negative 10. So it's not going to be that one, right? 5 plus 5 is 10, but I need a negative 10. So how about negative 5 and negative 5? So just so happens my binomials match. A minus 5 times a minus 5, and a more concise way to write that, and you'll see me do that all the time, is to write that as a minus 5 quantity squared. Good. I would encourage you to pause the video, and I would like you to do this one. All right, let's see how you did. So we're looking for numbers that multiply to 42 and add to 13. There's a couple of ways we can get to 42. 1 and 42, 2 and 21, 3 and 14, 6 and 7. And the only 2 that are going to add or subtract to 13 is going to be 6 and 7. Your answer should look like this. Either x plus 6 times x plus 7, or reverse it, x plus 7 times x plus 6. Okay. So when we get to this next one, I think as you look at it, you're going to start to say, wait a second, everything we've been doing today did not have a number in front, right? It was a 1x squared, or a 1a squared, or a 1t squared. Now we have a 3x squared. But don't forget, what we talked about in our last lesson is look for a greatest common factor. All 3 of these terms can be divided by 3. So let's pull that 3 out in front. So if I divide every term by 3, I'm left with x squared minus 11x minus 12. The 3 can't just disappear, it has to stay there. We don't want to change the value of the expression, we're just changing how it looks. And now we fix this, call it a problem. It wasn't a problem, but what made this one different? So the 3 stays there, and now I'm going to factor this. I'm looking for numbers that multiply to negative 12. Well, we'll deal with the negative later, but let's start with a 1 and a 12, a 2 and a 6, a 3 and a 4. I need them to add or subtract to negative 11. So if I want to get a negative 11, let's use a negative 12 and a positive 1. So again, don't forget the 3 has to stay there, but then my binomials are x minus 12 and x plus 1. Good. All right, let's flip it over and do 2 more. All right, so just like the one we did, I'm looking at this going, oh my gosh, look, all of these have a negative and they all have a 10. I say we factor out a GCF of negative 10. And when you take that out, remember when you factor something out, you're really dividing by a negative 10. Dividing by a negative changed all the signs. So they were all negative, now they're all positive. And then we get a 1, a 2, and a 1. I love how small these numbers are. We're looking for numbers that multiply to 1 and add to 2. Don't lose that 10, negative 10 out in front. Well, the only way you can get a 1 is with a 1 and a 1. And if I need the add to positive 2, then I think they both need to be positive. And I'm just going to rewrite this as negative 10 times x plus 1 quantity squared. Good. All right, last one. So when we look at this one, I mean, here they were all negative. Here, only 2 of them are negative. But what I don't love is that my leading coefficient is negative. I'm never going to want to factor with that. So I am going to pull out a negative 1. I know that doesn't have a negative, but that's okay. You can always take out a negative 1. All it's going to do is change all of the signs. So instead of negative, positive, negative, now it's positive, negative, positive. Okay? And that's what I want. I always want my leading coefficient to be positive when I'm factoring. All right, so we are looking for factors of 55, things that multiply to 55. Well, 1 and 55, 5 and 11. And I need them to add to negative 16. I think the only way to get there, 5 and 11. So it's a positive 55, meaning they need to have the same sign, and they both need to be negative, right? Because a negative 5 and a negative 11 gets me to negative 16. And so that would be factored completely.